Welcome to my project where we discussed about the process efficient feature learning of retrieval based structure image. Feature extraction process in the classification is domain adaptive genetic features methodology. By using this algorithm to classify the relative images to consecutive input image in the trained database, so to check the fitness criteria from the input image to classify the output image as solution for the features to descriptors of the input image. The visual analytics is the human machine descriptors of the input image plays the important role. Although the feature extraction is the multi-objective task, the traditional algorithms extraction is only considered one objective or aggregate the objectives into the one scalar criterion to optimize. In this paper, we propose a Pareto-based multi-objective approach to feature extraction for visual analytics applied to data classification problems. We identify the classifiability, visual interpretability, and the semantic interpretability as the three equally important objectives for the feature extraction in the classification problems, and define various measures to quantify the objectives. Our results on the number of benchmark datasets shows consistent improvements compared to three standard dimensionality reduction techniques. We also argue that the exploration of the multi-Pareto optimal models provide more insight about the classification problems and opposed to the single optimal solution. Image classification can become active research field in computer vision due to its wide range of applications. Image human computer interaction, the basic image classification algorithm is generally introduced and involves two main stages: low level feature extraction and representation, and feature learning for image classification via multi-objective genetic programming high level image. This is flow of our process efficient feature learning of retrieval based structure image. In this process, we have to take the input images, several relevant images to like as a car, flower, and transformation, traveling, etc. That input images to give the output for after the classification process accurately to give the image normalization, multi-objective genetic processing, and optimal image descriptors. Evaluate the testing data. The evaluate testing data is queued as the classification performance. The optimal image descriptors is queued the relevant images, and then multi-objective genetic processing is a feature extraction process of for our input image. And secondary image is to be the classification process of primary feature extraction. In this step, we take the input images as the different kinds of images for classify the input from the trained database. The resist the image for further steps of classification process, and then we have to extract the features, the important process to find the relevant images, and finding the pyramid feature extraction of the input image. We have to separate the pyramid values of different kinds of images of the input sector, using those feature values to take the values as a test values for the extraction. For those, apply on the all pyramid properties and create the feature values for the classification. The final step is to the threshold calculation. This is very helpful to the feature extraction, and then the classification. The classification is process is to be the RGB image finally concurrent the all parts of the single image value, and then there is evaluation method to measure the performance of the extracted images to multi-stream classification methods. Using calculation to evaluate the performance of that classified images for accuracy measurement. This is very useful to know those classification methods to how works and what is performance ranges occurs on classification process. This is the MATLAB main window. In that main window, we have to listen the current folder command window and then workspace of our process. In the workspace, we have to save the all variables, function, and values of that using the coding in our process. The command which is stores when our process obtained in the command window of our process. The command window is to be execute the all coding and variables and values of that process. கேட்கல. சொல்லுங்க மேம். மேம் கேட்குதா மேம்? மேம் என்ன மேம்? ஆமாம், எக்ஸ்ட்ரா 5 இமேஜஸ் ஆட் பண்ணி கொடுத்தோம். ஒரு டேபிள் போட்டு கொடுத்தோம். வேறு என்ன கொடுத்தோம்? ம் 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 அப்புறம் வெர்ஷன் என்ன இருக்கான்? அதான் இல்லையே, வெர்ஷன்லாம் ப்ராப்ளம் இல்லையே. ம் 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 வேல்யூஸ்லாம் கரெக்டாக தான் இருக்குது. டேபிளே டிஸ்பிளே ஆகலன்னு சொல்லுது அந்த பொண்ணு. வந்து ம் வீடியோ எடுத்து அனுப்பிடுவா? சரி. ம் சரிங்க மேம். ஓகே. சரி. சரிங்க மேம். சரி. In that current folder we have to choose the file, the main.m. The main.m file is a main file of our process. Right click the main.m and click the run file. Then after the click the run file, we have to display the our MATLAB main display. Wait a minute to display our MATLAB output for our process. The MATLAB output is to be very effective and case sensitive and very sensitive process to be obtained. This is the output window of our process, the first display, and then controls to be obtained in the buttons, the input image and features and retrieval and performance also. Click the input image. Clicking the input image to this is folders of our input and subfunction obtained in our process. Click the data set. We have to choose the medical image and flower image and building image and transformation and fruits and humans image of our relevant images of our process. I have to select the medical image, the brain image to be for input our process. After clicking the input, we have to display the input image of our process. This is the input image of our process. Click the features button. After clicking the feature button, the pyramid features to be extracted from the input image to obtain the entropy values and to such feature extraction values of our process. This is a window for feature extraction, pyramid feature extraction, and then the values to be displayed in that list box, such as the entropy value, SLV value, correlation value, homogeneity value, histogram value, and variance value, pyramid coefficient, sum of edge, contrast value, mean energy value, and that those values are very effective to calculate the features to help. This very helps to the classification process. Click the retrieval button to retrieve the relevant images for taking input. The, the relevant images to be very effective than using the multi-assign classification method. Relevant images to be obtained in that window, the figure 115. The figure the image 1, 2, 3, 4, 5, 5 images to be calculated, the relevant images for our input image. The final image to be displayed in the main window. Click the performance button to calculate the performance values of our process, the accuracy, sensitivity, specificity like that. That tables display the feature value. Tables display the pixel values of our output image. The pixel values to be displayed for example one image to be displayed in the table. The relevant images to be displayed in that window for process. Now we have to conclude our process. We have to take the input images such as flower image, fruit image, human image, and medical image also. The feature is to be extracted from the pyramid features and to be classified, the retrieve the process of the relevant images using the multi-assign classification to be performance is Performance is to be calculated from the class MATLAB default function.